Hello everyone, welcome to the channel Statistica Hub. So this is our lecture number 5 on in the course SH201A. So in this lecture, we are going to cover the total probability theorem and the Bayes theorem. Okay, so the concepts are like very easy. Just step by step, we are going to understand the meaning of total probability and the Bayes theorem with some sort of application. Okay, so as the name says, let's take up the first part, the total probability theorem. Total probability theorem. Okay, so that means to say there will be some event that can be occurred in different forms. Okay, or maybe in some different ways. Okay, so let's consider some example maybe. Okay, assume that you are staying in Mumbai. Okay, and I'm coming up to meet you. Maybe I have to meet you. Okay, you are at your house. Now to meet me, you have like various options. So let's assume that I'm waiting for you on the airport and you have to come and to meet me. So you can have various options. Maybe you came out of your house, you get your own bike, and then you meet me. Okay. Or you came out of your house, you get a cab and you meet me. Or the third option, you came out of the house, you go to the metro and you meet me. So finally, the event that we have to go for the event that we are going to meet up. So in this particular scenario, you have to calculate probability that you are going to meet me. So what will be this probability? So we know the meeting that can happen maybe in this first way, or maybe in the second way, or maybe in the third way, correct? So that's how we can define the probability or the different cases in which we can get the probability of final the meeting up. Okay, so in this part, you can see these three events or these three different pathways, they are coming out to be like completely independent of each other. So we can go for the concept, like if I say probability of meeting me up, that will be probability of getting a bike, okay, into probability of meeting me, given that you are coming from the bike. The first way, like I can simply see this particular part, that is nothing, that is bike and meeting. And in the last lecture, we just went through some concept of like multiplicative rule, in which we covered one thing, that first one event must have occurred, and just after the first event occurring, the second event that has been taken up place in this particular part. So we are going to move for like probability of B. Okay, that was the first case. Like this can be expanded probability of bike into probability of meeting, given that you are coming via the bike. Okay, moving ahead. So in this particular setup, probability of B into probability of M given bike plus probability that you are coming from cab and then you are meeting me. The third case can be probability of getting into the metro and probability of meeting me, given that you are coming from the metro. So that's how the final probability that can be occurring. And this particular property or this particular kind of probability that is coming out to be like probability of meeting me up. And this is the concept of total probability theorem. So in more general setup, if you have to understand what is the meaning of this thing, so we can make maybe one diagram that you are having some sort of like disjoint events, maybe some event A1, some event A2, some event A3, some event A4, some event A5. Okay, so in all of these scenarios, if we just move ahead, then if I say there is some event like this, so you can see this final event, let's say some event maybe K. So this event K that can be occurring in this setup, that can be occurring at this place, can be occurring in this part, in this part, in this part, or in any of these part. So you can see probability of the event K, that will be probability of K and A1 plus probability of K and A2 plus probability of K and A3 plus probability of K and A4 and finally probability of K and A5. So that's how we can write the final probabilities. So this is like you can have multiple setups. So this is the concept of total probability theorem. I hope that makes sense. This is an easy concept and that's how we can deal with the concept TPM. Okay, moving ahead. Okay, we are having some sort of example. So in this example, we are given a factory has 3 machines. Okay, machine A produces 30% of the items. So you are having some machines A, machine B, machine C. This is producing 30%. This is producing 50%, and the final, this is producing 20%. Okay, the defect rate for the machines are this, and this. Okay, so probability of getting defective item, you are in the machine A, that is 1%. Probability of getting a defective item, you are in the machine B, that is 2%. And probability of getting a defective item, given that you are machine C, that is 3%. Okay, if you move ahead in this particular part, then they are saying what is the probability that a randomly selected item is defective. So you have to find probability of defective. So again, very simple concept. So it can be like probability of A and defective plus probability of B and defective plus probability of C and defective. So that will be coming up like probability of A into probability of defective given A plus probability of B into probability of defective given B plus probability of C into probability of defective given C. So moving ahead with this part, so that is 0.3 into 0.01 plus 0.5 into 0.02 plus 0.2 into 0.03. So if you solve it, this will be coming out to be the total probability. Okay, I'm not going for the calculation. You can try the calculation. Okay, so that was an example about total probability theorem. Okay, moving ahead. Okay, now we have to understand something about the Bayes rule. Okay, this is the last topic in the basic probability theorem or the basic probability course. After this one, you will find like one more lecture, but that can be like after some sort of gap in the add-on topic. Like you go to the different steps on the website, you'll be finding like one particular step that says add-on. In the add-on, I will add some advanced topics, maybe some sort of like rules, some sort of theorems that are like not in the very basic concept, maybe the Boole's inequality, those type of inequalities that will be there in the advanced or the add-on one. Okay, the people who are like watching this particular lecture and following the YouTube, the website, then they will able to understand like what I'm trying to say. The add-on one, we'll find one more lecture over there. Okay, moving ahead, now we have the Bayes rule. So the Bayes rule, we can see this is simply, we are having some sort of like reverse probability. Reverse probability. So what does that mean? They will say that this particular event that has already been taken up. Okay, one event that has occurred. Now you have to move back and you have to find that this event occurred via this particular method. Like we know if you have to meet me, this is the final event, you have to meet me. So if you are at your house, then you have to first decide to get a bike, then to meet me. Get a cab, then to meet me. Get in metro, then to meet me. Correct? Now, if I say you have already met me, now find the probability that you are coming via the cab. So this is like reverse probability. Like first you have to get the cab, then you can meet me. But we are moving like in the backward scenario that you already met me. Now find the probability of getting a cab, that you are coming via the cab. So this is like the reverse probability. So you have to find probability that you are going to choose the cab given that you already met me. Okay. So if I just say this is M dash, so that you don't mess up with the things. So this will be again the probability of M and C divided by probability of M. And probability of meeting that we already calculated. So the denominator part, probability of M, that is technically the total probability. And how that is coming up? So that will be coming up like probability of bike into probability of meeting me up, given that you are in the bike, probability of cab, probability of meeting me, given that you are choosing the cab, probability of choosing the metro, probability of coming via meeting me, given that you are coming via the metro. Total probability. Now this is like M and C, like meeting me and you are coming via the cab. So you can see this part, that is that particular probability. So that is coming out to be probability of cab into probability of meeting me, given that cab, divided by probability of M, that is this particular probability. So this particular theorem is known as the Bayes theorem. And again, a very easy concept, the reverse probability. The people who are like more into the Bayes rule or the Bayes probability, there is one more lecture series on our YouTube channel. You'll find like, I think the code is SH201A. Yep. Most probably this will be the code. The code can be different also. You can just check out. You will find one particular lecture series, Bayes inference, or maybe the Bayesian inference. In that one, you will find the Bayes rule in some applied format in the course of like inference. Okay. Only for the people like who are interested. Else you will start and then you will just stop in between. Okay. So that is about the Bayes theorem. I hope you are able to understand. Moving ahead. Okay, again, we are having some sort of example. Let's try to have a look on this example. So a test for a disease is 99% accurate. Okay, that is true test and true negative. Okay, true positive, true negative. If 1% of the population has the disease, what is the probability that a person has the disease given that they tested positive? Okay, so we are given probability that the test is like true. So I can say the true test that is given to be 0.99. Okay, and the population is having disease, that is probability of getting a disease, that is 0. What we can say 0.1. Okay, very simple concept. So I can just simply see this is like the test will be accurate. I can just change this part. This can be written probability of getting a true test given that D is there. Okay, just consider T to be like true positive maybe. Okay, this is given to be 0.99. Okay, now if you go for probability of test being a positive, given that a person is like not in the disease setup, so that will be just a positive of that one, 0.01. Okay, and probability that in the population there is no disease, so not a disease, that is 0.99, just a positive of this one. Okay, now we will calculate like what is the probability that a person has a disease. You have to calculate probability a person is having disease given that his test is coming out to be positive. Okay, so that can be written probability of disease and test to be positive divided by probability that the test is positive. So this part, total probability. So probability that the test is positive, that can be in two different setup. It can be positive when there is some disease. It can be positive when there is no disease. Okay, there is disease, these two multiplied and these two multiplied. So you are going to get 0.99 into 0.01 plus 0.01 into 0.99. Okay, and it is saying disease and positive, that means to say this part only. So I'm getting 0.99 into 0.01 over total probability 0.99 into 0.01 plus 0.01 into 0.99. So that's the probability that we are getting. So I think I'm going to get 1 over 2. Okay, so that is 0.5. So that is a application of the, or we can say some example that is based on the Bayes theorem. So Bayes theorem and the total probability theorem, they come in hand. Like you have to apply the total probability theorem, then we are going to move to the Bayes theorem. Okay, moving ahead. Okay, we are having some applications for the Bayes theorem and the total probability theorem. So, okay, this is some sort of like spam filtration. Okay, an email filter is designed to identify spam. Okay, so you see like many times you get some emails and they're coming out to be like in the spam folder. Okay, suppose that 95% of the spam emails contain the word offer. So the probability that you are having the word offer, given that we are having the spam, okay, spam emails contain the word offer, that is given to be 0.95. Okay, and 1% of the legit emails contain the word, okay, probability that you are going to get the offer given that the mail is fine, that is 0.01. Okay, if 20% of the emails are spam, so probability that you are having the spam, that is 0.2, and probability that we are having the legit, that will be 0.8. Okay, what is the probability that an email is spam given that it contains the word offer? So you have to calculate probability that we are having the spam given that there is some offer. So probability of spam and offer divided by probability of offer. Again, a very simple thing. We have to calculate probability of offer. So you may have some spam, then you are having the offer, or you may have some legit, then you are having some offer. So again, if I calculate this part, that will be 0.2 into 0.95 plus 0.8 into 0.01. And for the numerator part, spam and offer, that is just the multiplication of these two parts. So that is 0.2 into 0.95. Simple concept. So you can just apply this, you can simply calculate this part, you'll be getting the final probability. Okay, again, I'm not solving it further, just the calculation part, you can complete it. Okay, moving ahead, then we are having one more scenario in which we can apply the Bayes theorem and the total probability theorem. So in this problem, it is given that a doctor uses a diagnostic test that is 90% accurate for a particular disease. Okay, so again, the same kind of thing. Let's say T that counts the test is positive. Okay, probability that the test is positive, given that there is some disease that it will detect, that is 0.9. Okay, and we are given the disease, that is probability that you are having the disease, that is 0.05. Okay, so again, the similar kind of problem that we just solved ahead. So probability test is positive, given that there is no disease, that will be 0.1. And probability that the population is having no disease, that is 1 minus 0.05, 0.95. Okay, moving ahead with this part. So you have to calculate finally probability that we are having disease, given that the test is positive. Disease, positive test. So that will be probability of disease and positive test, that I have written T, probability of T. So that is moving ahead. If you move ahead, so this will be coming up like multiplication of this part. So 0.9 into 0.05 over 0.9 into 0.05 plus the second case 0.1 into 0.95. So that's how you can apply the Bayes theorem and the total probability theorem in the course of like medical science. Okay, so this was all about the total probability theorem and the Bayes theorem. I hope you are able to understand our module number 1, that is about the introduction to the probability and some probability concepts. Okay, so like with each of the slide, you'll be able to find some practice problems. There will be some like very, very easy problems. So you can just try them out so that you get an idea how to apply these concepts in the numerical problems, in the mathematical models. Okay, so this was the module number 1. In the next lectures, we are going to start the module number 2 that will be covering the concept of random variables. So that's all about this lecture. I hope you are able to understand. Thank you. Bye.